Hello, Manvi, are you there?
Yeah, hi Lakshita. Yeah, I'm here.
I'm Varsha, coordinator of this webinar. A warm greetings. It gives me great pleasure to extend a warm welcome on behalf of GC BANKA Department of Science and Technology. It's conducting Parvaa Tech Fest 2021. At first, I'd like to introduce about Parvaa Tech Fest. Parvaa is annual tech fest of GC BANKA. It was started by GC in 2020. This year, we are conducting it at national level. This event was started on 5th of June, and today, 7th of June, we have a webinar on workshop on Tinkercad and GitHub. Lakshita ma'am, now you proceed.
May the setting sun take down all your sufferings with it and make you hopeful for a new day. Good evening to all. I hope you had a good day and productive day. Cheer up. Today we have a workshop on Tinkercad and GitHub by my dear friend Manvi Jha, leader in Developer Student Club NIT Patna from Hardware Department. She has amazing skills like web development, C, C++, Python, JavaScript, English, public speaking, etc. What I can say about her, she is totally amazing. We are very fortunate to have you, Manvi, in this workshop and welcome you for this workshop. And I am handling this to Manvi. You can start now.
A very good evening to everyone. Thank you so much, Lakshita and Varsha. That was a very good introduction, and really thank you for appreciating me so much. Welcome everyone. I'll start sharing my screen now.
Yes, Manvi.
So, I hope my screen is visible to everyone.
Yeah, it's visible.
Okay, I welcome you all on the workshop based on Tinkercad and GitHub, and I hope that you have a quite knowledgeable time with me here. So, initially, I'll start by telling a bit about me. My name is Manvija, and wherein we are unable to meet physically and get working on different projects, and it's just not very possible to work on great hardware projects by sitting at our home and just not having access to all those hardware equipments or meeting each other in person. But impossible or very difficult, that is not a word that should be present in the dictionary of developers. So if you are a developer and you feel this is like a hard time, I think we have softwares to our rescue, and that is what we'll be exploring today. So let's just get diving into what solutions we have to develop hardware and in order to collaborate while developing, because collaboration is one of the most important things. When you work in a group, you might have good ideas, you might have good project things in your mind, and you might want to work on them. But the point is, you just can't do everything alone. So doing things online and collaborating for them online are two very important things. And today I'll show you the best software solutions to them. So, first of all, whenever we talk about hardware projects, for which I'm sure we're all here together to know how we can develop in hardware sitting at our homes. So, one thing that we should all know whenever we're working on hardware projects using our different uh, Arduino boards or maybe Raspberry boards, we're actually delving into the field of is something like, a network of physical things, things which can be, bulbs or refrigerators or any embedded systems or electronic devices. When you interconnect them so that they act according to commands given at one particular end or according to your requirements, be it your voice commands or anything, such kind of interactions that you make, such kind of internets that you make, is actually called Internet of Things. And this is one of the things that maybe you all are actually aiming towards into this tech fest of yours, because that is why you're wanting to make hardware projects. So what you are wanting to do is you're wanting to make things interact with each other. Maybe it could be a small project like a light bulb turning on when you sense a particular temperature or with a particular touch, or maybe a motor car working through remote control or maybe through your phone, something like that. So all of these things which you make, you're actually making things which are like the light bulbs or the cars or anything. You're making them interact with other things like your touch sensors or your mobile phones or anything. So this interaction or this internet that you create, That is what we term as the Internet of Things, and the things are basically the sensors and the embedded systems included in them. So how does it basically work? Now, this is something very important. When you start with your project, you should always know the flow in which things are going to work. It's not random. Everything has a certain process, a certain path. So when we start with our hardware projects, when we start creating something, it starts with the point of sensors and actuators. Sensors and actuators can be thought of as electronic devices made specifically to work for a particular circumstance. For instance, touch sensors, they send signals of positive and negative when they are being touched. If you touch it, it sends a positive signal to the microcontroller. If you are not touching it, it is continuously sending a negative signal to the microcontroller. So sensors and actuators are what make the base or the ground level of any hardware project that you'll start working on. They are like the things that you actually see. You are not going to see the microcontroller or the connections or the cloud. You're actually going to see these sensors working. And that is why you should choose your sensors with a lot of caution, and you should study first before choosing any sensor. I've seen people who just go to the shop, buy any kind of sensor, and they want it to work according to their desired project, but that's not how it works. There are many specifications you should keep in mind when you're choosing a particular sensor for a project. Now these sensors, they sense your environment, they sense your required thing, maybe your temperature around you or the humidity of the soil or your heartbeat, whatever it is sensing. These sensors send their sensed data or the collected data to the microcontroller. The microcontroller can be thought of as a device which can be programmed to work according to the input taken by these sensors and actuators and give them commands for further work. So microcontroller are basically the motherboard, you can think of it. They are the ones that have the codes to work accordingly. They take in the input, give in the output, they command the entire process to work. Now the data that you send to these microcontrollers, they are actually stored in a cloud, and the cloud is a very important thing of any hardware system, because many of the times you want to store a huge amount of data and then work accordingly. It might be, for instance, a truck system. You want to store, you want to transport ice from one point to the other using a truck. You have installed a system in a truck that would sense if the ice is in frozen state or if it has started to melt. And you can sense where the truck presently is, like for the destination. And you want to sense maybe the state of the fans inside it, or state of temperature or anything like that. So you just don't want to sense it, you want to keep a record of it, or you want to command the sensors accordingly. If you see the graph of temperature going suddenly increasing, you would want the fan to start at a certain point. So you want to store the data somewhere, then you want to work on it. So the storing process, or the way in which you can act according based on your past information, or you could say to maybe you would want to study a certain stat and that's why you want to store it. So there are a lot of reasons you would want to store data. And in most of the hardware projects, storing data or using cloud for interfacing is a very common thing. So cloud connections come next to it, which are important if you work on big projects, or even small projects do need cloud data. Many a times, even if you want to send your data directly to the phone or to some website, you would definitely need to use a cloud interface. And after your entire system is set, the microcontroller is accordingly coded, the sensors are set at their places, the cloud is properly connected to take in and give out data. You start your system, and that's when it starts to act. So these are the important steps. So you could say a flow that needs to be followed whenever you start making your hardware project. Okay, moving on next, I would like to introduce you to some very interesting hardware projects that we have around us. Some of us might be aware of it, some of us might not have heard about it, but these are a few fascinating projects and personally my favorite ones. So on the top of the screen, we see a project named Happy Fork. So Happy Fork is something that allows you to monitor your eating habits. You use this fork to eat whatever you eat during your entire day routine, and it has been connected, like it has sensors, of course. These sensors sense data to the microcontroller, that is fit inside the spoon, and then this data is sent to the cloud, which then transfers the data on your mobile app. So it displays how much food you've eaten, if it's healthy for you, if it's not healthy for you, if you're crossing your daily fat level and all, and if you're not eating on time. So it's just a fork to track all your eating habits, to track your maybe your fat if you're on a diet, and everything. It's just a good thing when you are too busy in your day to maintain a proper eating routine, and that's when Happy Fork comes to your rescue. Next, we have Smart Propane Tank. So this is sort of a device. It's just written propane. It's not necessary just use it for propane gases or anything. This is like, you fix it to a tank. This sensor or this inbuilt tank sensor system, you fit it to a tank, and then you automatically get the amount of gas or water present in that tank on your mobile phone. So it's like a good thing when you know when you want to refill your tank, and you can even fix it to your vehicles, and also that you have like a complete status of the amount of fuel you have in your vehicle or the amount of water you have in your tank, and when it's time to refill, all in your mobile phone. And definitely the smart lighting system, we all have seen its advertisement on our televisions, the smart lighting system. And you would love to know that this basically is a hardware project. Smart lighting system, many people confuse that it's like a big developed software project, something of a very high level, but no, it is a very, very basic hardware project. In fact, if you guys want, you can design one for yourself at your own home, and it won't take much of development, much of knowledge. It is a very easy project. All they've done is connected a series of bulbs, and they have a command line, and they have a code commanded to the microcontrollers that whichever color has been selected in the app, that color data will go to the cloud. Microcontroller will take the data from the cloud and would send commands accordingly to the LED sensors that, okay, this is the color you want to turn your bulbs onto. A very basic project, but how beautifully it comes out to the world, how useful it comes out, is what makes it amazing. So these are a few small projects which are easy to make and yet are very innovative, and you could say very trending in today's world. So moving on next, I would like to know, maybe you can put it up on the comment section, where are the areas where you have seen IoT applications around you? It could be somewhere just next to you, somewhere in your neighborhood, in your house, at your college, anywhere. Any example that you have seen in your daily life about IoT applications? And I don't know if I can get the comments that you're putting up, if somebody can read them out to me or anything. Lakshita, is it possible to read out the answers if they're coming in the comment section?
Yeah, Manvi, I'm saying. Actually, Manvi, we didn't get any comment right now.
No issues. You can think on it, take your time, and put up the answers. It's like an innovative thing. You can just look around yourselves and see where implementations of hardware have been done around you. It can be something very small or something very big. It's easy. You can figure it out. You should definitely try it once. So maybe you can keep it as an innovative assignment to think about IoT applications near you. So if we have no comments regarding this, maybe we can move forward. Okay, so now we'll be getting on to making our own hardware device. So before I get into actually delving into Tinkercad and telling you how to make it virtually, I think it would be a big loss if you don't know about what physically these systems are. So I just wanted to give an overview about what physically these systems look like, and maybe when you'll use them, you'll have a good idea about it. So these aren't very costly. If you want to experiment, you can always buy them. You can find them anywhere, like online or even in any hardware store near you. So basically, we have three main microcontrollers. The three pictures that you see here on your screen are that of microcontrollers. So The first microcontroller, it is the most famous one for obvious reasons that we'll be discussing. This is Arduino Uno, and this is something we'll be working with today in our workshop. Next, we have ESP8266. People refer to it as Node MCU also. And then, of course, we have the mighty Raspberry Pi. Now, all three of them have their own advantages and disadvantages. For instance, if we talk about the very famous Arduino Uno, it has a lot of digital pins. It is very easy to work with, provides all sorts of functionalities, and you can connect it with your laptop and with an external battery and everything. But the drawback that it has does not have an inbuilt Bluetooth or Wi-Fi module. If you want to use it for some Bluetooth purpose or some Wi-Fi purpose, you'll have to attach a Wi-Fi module to it and code it accordingly. And that is one of the benefits with ESP8266 or Node MCU, that it has inbuilt Wi-Fi in it. But the issue with it is it has very few analog pins. Like the analog pins we have in Arduino are around 5 to 6, and that those that we have in ESP8266 are like 1 or in some cases 2 that way. So that is one of the issues with Node MCU. But then, of course, there isn't any issue with Raspberry Pi. Raspberry Pi is like your mini CPU. It has everything in it. You can attach an external LCD or speaker or anything. And it has you can attach pen drives. It has inbuilt memory and Wi-Fi and Bluetooth. Obviously, it is like the mighty board. So you can definitely go through more details of these boards when you use them physically. But an online system, all that we need to know about these are about its digital pins and its ground pins. That would be the maximum of what we might be using. So are we ready for some small projects? So before we delve into making our own projects, let us have a small view over the project that were made in past few sessions by the DSC group that I was heading, and a few of the members of the group, we assigned them projects and they came up with really innovative ideas. So I would like to show a few of the projects that were made by the students of DSC at NIT Patna, and they were really good. I really hope you like them. So the first one was that of a gardening system. This was also made offline at one of our workshops, and then a few students turned it into an online model. So what this does is it basically tests the humidity of the soil and turns on the motor accordingly. If the humidity is less, the motor would be turned on and would go on until you reach the required humidity level. If the humidity is high, the motor shall automatically be stopped. It is like an automatic gardening system. You don't need to move your hands or mind into working it. You just install it and then you're safe and sound with all your plants. Maybe you'd need to do a bit of weeding, but nothing else. And then we had this project about temperature alert. It alerts you about the temperature in your surrounding. It was later also attached with mobile applications so that you get emails if the temperature of your room is increasing, and if it's at a very high level, you might get phone calls from the device itself that the temperature of your room is increasing very high. Maybe your room is on fire, or maybe you left something on, or you need to check there's something wrong with your room and its temperature. So this was another project made by the students at DSC. And then there was this project about know the gases. So you could hear the beeping sound. Basically what it does, it checks about the concentration of different gases present in your room. So you would know what are the gases you are surrounded with, if the environment around you is healthy or if it is not. It was more for a commercial use than for personal use. It can be used by researchers or maybe environmentalists to have a look around their environment and see what kind of gases are present, if the concentration is fine, if the environment level is fine and all. And the buzzer was basically put up there to make the project look more interesting. The buzzer was not of much use. The main use was of that LCD, which was completely displaying the amount of which gas is present to what concentration and all. So these were a few very small projects, and I'm pretty sure you guys must be excited about how these projects were made, and you might be looking forward to make your own projects. So for that, I'd be introducing you to Tinkercad. It is really interesting platform. So before you get started, I would like you to know that you need to just go into this Tinkercad, search it on your web browser. You need to create an account. If you're working on a group project or if you're leading some project, you can go on for a teacher or a student account. But generally, people prefer, if they're working on their own projects, they prefer to make a personal account. So you can always make a personal account over here. There are some inbuilt projects present. You can make your own projects, and I'll just give a quick walkthrough about how you do that. So when you log into your page, you get something like this after creating an account. Creating an account is really simple. It does not ask for much detail, just your name and email. And then you go to the circuit section. Like, it has many things you can code here, you can have some lessons and all, but we'll be focusing on the circuit section. And then you can create a new circuit, or you can go for some past created circuits. These are a few circuits that I had created. So you can go for some inbuilt circuits also. So I'll just show you one of my created circuits here. Just a minute. Yeah. So this one was made by me like yesterday, I think, when I was preparing for this workshop. So one second. Yeah. So when you start to design, this is what your screen would look like. Sorry for this. Yeah, this is what your screen would look like. It won't have the Arduino and all. This is just because I've opened a project. Now, what you need to do is you need to search here for the devices you need. Like, for instance, here I have used an Arduino Uno, 3 LEDs and 3 resistors. Resistors just so that the LEDs do not get more power than what they require. And now you need to make the proper connections. Like here, one of the connections, one of the wires for the LEDs would go to the ground, and the other would go to one of the digital pins. Now this is where I would like to start explaining things. First of all, this Arduino board, if you can see, I'll just zoom it a bit. One second. Yeah. So if you can see in this Arduino board, there are a few numbers written. Now these numbers basically represent digital pins. We all know that there are two kinds of signals that we get. One is digital and the other is analog. While digital is only about zeros and ones, analog can have any value, any analog value. And generally when we're dealing with Arduinos, it ranges from 0 to 255. So in some sensors, it also ranges to 128, but in general, it can go to 225. So these numbers that you see written here are actually digital pin numbers. So whenever you put in a wire or a connection to one of the digital pins, you're actually marking it for your coding standards. Now, these numbers are marked, and the board is designed such that if you write any code based on any of the number pins, you're actually programming that pin to work accordingly. Things would get clear when I'll go with the coding part. And then we have ground here to ground our circuit. We all know what ground means. And if a reference is not of much use to us. And then below, on the lower side, one second. On the lower side, we see analog pins. These A's that are written, these are actually analog pins. So if you connect a sensor up here, you can get analog values. Okay. And now for a voltage supply, generally if you are, generally if you're connecting anything, yeah. Generally, if you're connecting any circuit and you've not put in any voltage point to it, you get a voltage of 3.3. Okay, but if you want, you can extend it to 5. It's that way. So there are two voltage points present, 3.3 and 5 volts, and then we have grounds, VN, analog pins, normal pins that we know about. So now coming to this circuit that I've made here, I have connected the 3 LEDs to pins pins 11, 10, and 9. And I have grounded the other side of the LEDs. I've attached resistors. So well, so good. A very normal circuit of 3 LEDs being connected to a board. Now we'll go for the code section. Now, one thing that you will notice, which is very good about Tinkercad, is you can code in two ways. The code that I have written here is actually written in C++ format, but you can also write it in blocks format. It will delete it, so I won't show I'll show the blocks way in a different project. So this is written in C++. I am sure most of us know C++ coding. It's just normal coding. There's nothing related to C++ much in that. So I'll explain it. If you remember, I just said that I connected three LEDs to pin mode 11, 10, and 9. So now these three pin modes actually are giving output, right? When I want them to light up under a certain circumstance and to light off under a different circumstance. So they're actually giving an output that, okay, when we have certain input, we'll blow this bulb up. So that's the output, the bulb lighting up. So we set these pin modes to output. Now the pins that were numbered 11, 10, and 9 are designed to give an output. This has to be written in void setup. Now there'll be a second function that would be void loop. Now void loop is for you to write your commands as to how you want the things that you defined in void setup or above that to function. Now, one thing that you should remember about void loop is that when you start your simulation, it would be continuously running, like it would go from top to bottom and then it would start over again. That is why its name is loop. It would just run over and over again. And this is something you should keep in mind because it would be a very important thing when you start to code. Now, what I have designed here is basically the three LEDs will blink one after the other, and the first one, that is the green one, would blink for uh, 1 second. Wait. The green one would blink for 1 second, the yellow one also for 1 second, but the red one is going to blink for 2 seconds. A very, 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 very basic code. So now what I'll do is, first I've defined the pin modes 11, 10, and 9. Now in void loop, I'll be writing the following commands. Now digital write, we are using the digital pin, and write means to set it to a certain standard. So we're writing that digital pin to a certain standard. Now, when I write, there are two commands with digital. One is digital write and the other one is digital read. So when you put digital read, you use digital reads when the pin is defined for input mode. So the program is coded such a way that whatever the sensor would be sensing in, that would be given as an input to that pin mode. So that pin mode would actually start to take an input. And in that condition, you will use digital read. But if you are giving an output, you actually want to write to that pin. So in that condition, you will be using the command digital write. After digital write, you need to define the pin mode that you want to write to. For instance, here I want first the green bulb to glow up. That is connected to pin mode 11. So I will write digital write 11 to turn on, that is high, which means high and low are two standards, of course, right? 1 and 0 are the only two digital values that we have. So when I write high, it would turn green bulb on. Now I want the other two bulbs to be set to low. Digital write 10 and 9 are to be off, that is, they are to be set to low standards. And that would happen for 1,000 milliseconds. Now delay is a command that delays the continuation of the code. After the code reaches this point, the next point is to delay. The next command is to delay, which means to stay stagnant, not move to the next command for 1,000 milliseconds. Now 1,000 milliseconds means 1 second, okay, because it's in milli. So it would wait for 1 second before moving to the next command. Now the next command says that we turn the pin 11, that is the green bulb, to low, and then turn pin mode 10, that is the yellow bulb, to high. Now the yellow bulb is going to turn on and the red bulb is again written to be low. And then we again wait for 1 second, and this time we turn the red bulb on and then wait for 2 seconds. Now, one thing that might pop up in your mind as a doubt is that why are we defining all the three pins again and again? We could just have written which one we want to set high and that would be it, right? If one of them is set to be high, that would be the one that would turn on, and that should be enough. But that's not true. If you set one of them to high and do not enter the command of turning it to low, it won't switch off. And as you know, it is a loop. It would move on again and again, and there's no command for it to turn off. So what would happen would be all the three bulbs would turn on for the entire period of time. They won't turn off. There would be no blinking. So therefore, it is important to mention the state of all of the pins at every level, so that you don't miss any one state. You don't let the previous state to be continued. If you don't write one of every the state of every bulb, maybe the previous bulbs would stay to their previous state, they won't change, and there would be no blinking. So unless you want the previous state to be maintained, you have to mention the state of every sensor at every step. Okay, so I'll just simulate it so that you can see how it works. uh, so it is simulating. Yeah, so I don't know if it's clear. It's green, yellow, and red. One second, I'll just zoom it a bit. Yeah. So it's green, then yellow, then red. Red stays on for a bit longer, that is for 2 seconds, and the other stays for just 1 second. A very, very, very simple simulation, a very simple code, and this is like one of the simplest projects you can work on. Okay, so and to get these components, I already explained, you can get these components from the search bar here. All of the components are present. You could see LEDs, registers, push buttons, even microbit. This is something that Tinkercad has introduced new to its functionalities. Initially, there was no microbit here. And then we have Arduinos, of course. We have vibration motors, DC motors, servers, and all types. So we have ultrasonic sensors, PIR sensors. Now, every sensor has a different functionality. Every sensor is used for a different reason, of course. The ultrasonic distance sensor, as you can see, and I am pretty sure most of you might be knowing, this sensor is used to sense the distance from the point you're standing at. It sends ultrasonic sound waves, receives them back, and tests the distance of the obstacle accordingly. So mostly this sensor is used in obstacle detection boards. You design a board that would detect an obstacle from a certain distance away from it, and work accordingly. If there's an obstacle, it would turn right. If there's an obstacle at left side, it would turn right, and accordingly. So if you want to make a bot that way, which would detect obstacles and work accordingly, you might want to use, they sense the temperature of your surrounding. Then we have photodiode. We have four flex sensors, which senses the alignment as to what angle you are aligned at. Maybe you're all vertical or horizontal, or maybe at a degree of 45 degrees or something like that. Then, of course, force sensor, as the name suggests. Then we have IR sensors. IR sensors are one of the uses of IR sensors can be thought of as designing a car that walks only on black lines, or that avoids only black lines. IR sensors are basically infrared sensors. So if you have a black region somewhere and you use an IR sensor, it would sense that that area is black. It won't go on that area. It would turn accordingly. So, we have many contests regarding these, when you want a certain a line following bot which would work only on the white lines or only on the black lines. And in those, I have mostly seen IR sensors to be used in those projects. So similar. Now then, of course, we have the gas sensor, which was used in the project I just showed you all. It used the gas sensor. Gas sensor can also be used to check if there is fire in your room. It can check the smoke and all. Although for that, we have our smoke sensors already present. Now, as I told you, there are some inbuilt projects here. You can see a few inbuilt projects already put up here. So if you want, you can use them, just to check out what circuits look like. Okay, so that was like a very small demonstration of how you can work with Tinkercad. If you want, I can just show you by connecting one of these devices again, as to how you get them out and work with them, because I used to have a lot of confusion with this thing. So I'll just delete these components, and we had a red LED there, so maybe I'll get back that LED and put it up again. So when you click on this LED, you drag it here. There'll be a dialog box that will ask you for color, so we definitely wanted a red one. Now we'll click on its cathode, drag it to the ground pin, and connect it here. The cathode is connected. We wanted a resistor, so we'll get a resistor. drag it and put it up here. You can define its resistance and all, connect it accordingly. Whenever you choose any of the terminals of any sensor or any device, it would turn into a red block. Then you can drag it and put it up wherever you want. So it's very simple to work with Tinkercad, one of the simplest things you can find for your hardware simulations. It simulates quite well. You can code here, but definitely it does not teach you how to code. So that might be a very curious question as to where we learn how to code these things, how to code a certain Arduino to work according to our desires. So when you work in offline mode, you actually use this software to code Arduinos called Arduino Ide. I'll just give you a look of that. Yeah. Hmm, this, wait a second, it's opening. Yeah. So this is what an Arduino IDE looked like. This was like the last project I was working on, so it's just open that. I'll just open a new window. Yeah. So this is what a blank Arduino coding window looks like. This is where you code your entire Arduino setup in a physical world, not in your online system. Definitely in an online system, you have your coding place already present. But in a physical world, this is where you code. You put up your codes, then you attach your Arduino to your laptop, and you just upload this. There's this upload button. You upload the code into your Arduino board or the Node MCU board or whatever board you're using. So you just put it up in there, and then it would work accordingly. Now, why am I showing this is because this Arduino IDE is distributed by, you could say, a company called Arduino, which prepares the Arduino IDE software and many more things. And there are few tutorials wherein you can learn about how to code with Arduino IDE. So I'll just show you. This is what the Arduino IDE website looks like. And then you could go into documentation, getting started, and just open up. So first, so it'll show you about how do you download Arduinos and its projects. Then you go to built-in examples. Now this is my favorite section. You get a lot of built-in examples here. So initially you can go for basic things like the commands that I told you, like digital read. You could say digital read serial is here. So you could go for small projects. These are very small projects like blinking an LED on and off. Then you could go for digital projects. These are the basic projects that are present here. And whenever you go for any project, all the commands that are used in it would be explained very well, the functions of that command, how and where you can use that command again and again. So if you want to learn more about how to code in Arduino or how to use those codes, or you want to go through a few basic projects before you develop something of your own, you might get good ideas from here. So this is the place where you would want to visit. Just go to the website of Arduino. It's arduino.cc, and you just get in here, check in a lot of projects that are already present up here. You go to the documentation section and read about its coding, and it would just be a very good thing to explore if you want to learn how to code and all. Now, I would just like to draw your attention to a few drawbacks that are present in Tinkercad. One of the most important them being that all the sensors are not present here. Many times we want to make projects which are very huge or which involve a lot of sensors, but generally on online simulators like Tinkercad, all the sensors are not present, like the touch sensor or the heartbeat sensor, the soil moisture sensor. These types of sensors are not present on Tinkercad. So that is like one of a very, you can say, minute drawbacks of Tinkercad. It's otherwise very wonderful to work with. So for those, we have a solution. Once again. So for those, we have a solution called Proteus. Proteus is a software, free software. You can download it. And for hardware projects, you can use making hardware projects which include like transistors or making PCB boards. It is used mostly for that, but you can use it for Arduinos. You just need to download a few libraries, put it up in a folder, and you're all set to go. So you can use Proteus. The good thing about using Proteus is that you can get all the sensors that you desire. You just need to download the library of that sensor, which is not a big deal. And the coding part for that is done on Arduino Ide. So you get a hands on how to work in real life projects. If you get an Arduino, you would already be very well trained to work with it. So, if any one of you want to delve in for big projects or there's something that you do not find very well in Tinkercad, you can always go for Proteus, and it is really easy to learn, though it won't be very feasible to cover it in this workshop. Maybe it can be talked about sometime later. But it is a good thing to explore, and it is a place wherein you can develop all kinds of hardware projects that you think of. Another drawback that comes for hardware projects in online mode is that you do not get to test the ability of the sensors, which is quite a thing because many sensors in real life work in different ways. It's not always that they work exactly according to the documentation. It is like a real life experience that some sensors are designed to work in the opposite way in which the documentations are written. For instance, one of the examples last time when I was working with raindrop sensors, which was supposed to test if there is rain and what is the intensity of rain and all. So it is basically an analog sensor. It gives you the idea about the density of the rain that's coming up and stuffs like that. So initially you would think that if we increase the value or if we're getting a higher value, it would mean that the rain is coming up more heavily. But that sensor was designed to work in an opposite way. So that was something that we were very messed up about when we were working with it. So it was like when the higher the value it shows, the less the amount of rain that's coming up. So practical applications of hardware projects are much different from what you can do in online mode. So that is one thing that you might be at a loss of if you're working with hardware. But I would suggest that these hardware components are very cheap to buy. So if you want to get an in-depth experience or an in-depth knowledge of any of the projects, just do not hesitate in buying them. They are really very cheap to buy, and you can afford them. You can afford them at least in a group project when all of you can contribute, those of you living nearby or something like that. So to get a complete hands-on, definitely software would never give you that. So for that, you can go for buying real hardware projects. But getting back to what we are focusing on, so this was like a basic introduction to Tinkercad, how you can drag in objects, create the circuit you want, write the code, and that is a very, very easy way to present your work. But how do you send this work to someone else? Like if you have made something, it's good. I'm sorry, is my screen visible? It's just something happened right now.
It is visible.
Yeah, okay. I don't know what happened. Just yeah. So as I was saying, so creating a thing is really good. It's a good thing, but how do you present it to the world? How do you send it to your evaluators, or how do you collaborate? If there's a project that you're working on which is quite big and you're like 5 or 10 of you working on it, so how do you end up collaborating with all 5 or 10 of them so that all of them can contribute, all of them can give in their ideas, give in their codes, or maybe you can collaborate, like one of them is coding maybe the sensors, the other one is coding the actuators, that way. So for that, we have GitHub to our rescue. I'm pretty sure some of you might be using GitHub on daily basis, but most of you would not be much accustomed to it, and that is what I'm here for today. So let us just delve into uh, GitHub. Just a minute. Yeah. So before we start, what is GitHub? It is like a big thing around the globe. Everyone who is into developing, who has ever done any development project, is always blabbering about GitHub. So what is GitHub? GitHub is basically a collaborative development platform. Initially, it was developed to, uh, make version control system to be an online thing. Like before GitHub, when people used to collaborate on projects, they used to use this version control system, which was very exhausting. It did not have features that would enable good collaboration and all, and it was difficult to collaborate with people across the globe or with those who are not around you every time. So for that, to seize that, you could say, problem, we came up with GitHub, and it is a real good solution. It is a place wherein you can store all the projects that you've made. So whenever you apply for a job or for some internship, or you want to flaunt yourself in front of anyone, all you do is just show them your GitHub ID, and they'll be like, "Man, you've developed so much." So you can store all your development projects. You can collaborate with people, and you can host your projects. Like in past years, GitHub has developed methods and features in which you can actually host maybe the websites or the apps that you make on internet, and you can make it public. Just hosting the websites that you've created, sending the links everywhere. You can make your own websites or your profiles and all. So it's like a collaborative development platform in one word, but the more you go on explaining about it, it has more to reveal. So one thing that you might have always heard about GitHub, whenever the term GitHub comes, people are like, okay, I have certain repository there, or you can contribute in this repository. So what is a repository? So a repository can be thought of as a container. Okay, like some drum or something that you have at your house. It can be thought of as a big container. A container that can store anything and everything in an organized manner. You can store files, folders, images, videos, spreadsheets, anything that your project needs. Any and everything can be stored, and it can be stored in an organized manner. The more organized you can keep it, the better you can have the access to it. And you can actually go back into history and retrieve when you have added what kind of files and folders, and if you have added something by mistake, you can just get one step back and delete that. So it's that way. It is the best way where you can store and organize your projects. So one project, one repository. For each project, you create a repository. In that repository, you keep all the files belonging to that project, like it files, folders, and images that I just said. So you create a repository for a project, you add files to it, and they're organized. So that is what a repository can be thought of as. It is a container that contains everything belonging to your project that you're creating. So I'll say let's start creating. So before I delve into more concepts of GitHub, I would like you to have a hands-on. So all of you who are following me, I request you just follow according to me. Like those of you who do not have an account, it's the best time to create. Just open a new tab in your browser and just move accordingly as along with me as my presentation moves. So initially, when you open github.com, you just open the GitHub, and this is the page that you'd see. GitHub is built for developers. That is it. Every one of us, we are all engineers. We are all meant to develop things and give it to the world, to develop huge projects, to come up with great ideas, and to rescue people in situations where they find no solution. So this is what developers do, and where developers do it, that's where GitHub comes. So when you log in to when you open the GitHub page, this is what you see. There you go for sign up, because for those who do not have an account, it's just a tutorial for them just to create an account. So you just go in, put in your username, email, password, small details, and you are ready to get into an account. Now, this is what a starting GitHub account would look like when you do not have any repositories or any projects. So from here, we'll start creating a repository. So, excuse me. So you'll see a new repository icon here, green colored. So if you're following along with me, it's okay. I'll be going a bit slow. It won't take time to create account into. And if you're not following along with me, so just bear me for 5 minutes till I go through the walkthrough. So you just click on creating a new repository after you have created your account. I don't think creating an account would take long. It is a very small process. And just don't go thinking much about your username. You can change it later on. So after that, you click on creating a new repository, and this is what a creating new repository screen looks like. So like we begin in every project with creating a Hello World project. So here we are, we'll create a Hello World repository. So this is what your screen would look like when you click on creating a new repository. Herein you put your repository name. You can put anything you want. You can change your repository name later, but I suggest think before you write your repository names, because whatever the name you put in, that would be the link that would be created. So think wisely before you make a repository name. Just don't go on changing it again and again. Then you can put in a description, which is an optional thing. If you want, you can add a description. If you don't, you just leave it. Then there's an option to make a public or a private repository. Now, public repositories are visible to any and everyone who open your account. Since you will be sharing your account with recruiters, developers, your friends, and everyone, so the projects that you want the world to see, you can keep them public. The projects which are personal, which are under construction, and you do not want the world to see them before they are created, you can keep them private. Many a times when organization works on big projects, big organizations, like most of the organization, in fact, all of the organizations in today's time, because we're all working in an online mode, all of them are working through GitHub, each and every organization. So if they're working on a new project which they do not want the world to see, they make it a private repository and give access only to those people who are involved in it. Okay, now then you can add a Readme file, gitignore license. Gitignore and license are not that important, but I always suggest that you should add a Readme file. A Readme file is like something that would open up when anyone opens your project repository, and it would have details about your project and details about how to run that project, or anything that you want anyone opening your project to know about. So that is one thing. Now, if you have created the repository, it would look something like this. Like, there'd be a Readme file. Since I've written nothing in Readme, so it would look just like a normal thing. And since I've added no files, so there'll be just a Readme file that I initialized early. And here there are a few things that we'd be talking about in due course.
Manvi, there is a query. Can I ask it?
Yeah, sure, please.
Zoya Khan is asking something.
Yeah.
What button do we use on mouse to
Pardon? Hello, Lakshita. Your voice isn't coming. I don't know.
I'm repeating, Manvi. What button do we use on mouse to rotate the workplace?
Which workplace are you talking about? Is it related to Tinkercad, or are we talking about GitHub Workplace?
Manvi, this is the question.
Okay, no issues. Since I haven't reached a workspace on GitHub, I assume it's a Tinkercad question. However, if you are like wanting to repeat, it would be fine. Anyways, if you want to rotate anything, it's just present here. You see the arrow keys. The mountain type structure that we have for rotation. You can just use it. It would rotate accordingly. And it's quite fun to see them rotating. So if you're talking about this workspace, so you have a rotate button up there so that you can rotate it. There are delete options if you want to delete any component that you have dragged in by mistake. There are redo and undo buttons, and you can add annotations if you want the other person to read something. You can hide components, and you can define the color of wires, and you can the color of wires can be defined here, and the type of wires, like you want hookup wires or alligator wires, or if you want the thing to be automatic, that can be defined here. So I hope if you were asking about this workspace, then this would do it. Also, you can export or share your projects from here to those who are already on Tinkercad, who have an account and you know about them. Um,
Manvi Divyans was asking, should any programming language required for this?
no, you
Because he
generally,
didn't know any
yeah, I can
programming
understand.
language. Yeah.
So generally, when I say that the code is written in C++, what I mean is that the formatting is done according to C++. Like we put semicolons and all. But if you go for Arduino in general, Arduino can be programmed in any language. Okay, it can be done in Python or Java or anything that you might be aware of. In general, like a general trend or the one in which Arduino Ide works is based on C++, but you do not need to know C++ for that. It's not like you need to be an expert in C++ commands or anything, because most of the commands that it uses are very unique to Arduino itself, like the words pin mode, digital write, delay. The other commands include serial display or digital read, analog read. So these are the commands that are unique to Arduino. So even if you don't know any programming language, you would need to know the language of Arduino, which can be learned easily from the website I told, arduino.cc, and then you can use it. So though it is written using the formattings of C, but you do not need to know C for that. You need to know the Arduino language. Any more queries?
Manvi, someone is asking, Tinkercad is free or not?
Yes, it's free. It's completely free. All of its functionalities are all free.
Okay, Manvi, now you can continue.
Okay, sure. Yeah. So where was I here? So this is like the page that you're gonna get. I think I talked about this page. So yeah, here I would like to show you what GitHub looks like once you have done creating, before we get into talking about different terms related to GitHub. So this is my GitHub account. I have been working on this account for like past 2 years. So this is like a well-developed account, you could say so. But initially, when you create your account, you won't have an introduction set page. You would have to add it if you want to later. So this is my page. If you want, you can definitely visit it. I already gave my account name and all. And then when you create a fresh account, all the repositories that you make will be visible. So I'll just open any random repository, like this one. It's just a random repo. Here I've added the solutions of HackerRank page for the Linux shell questions. So this is the README. You could make interactive READMEs. This is just a random one. And here you could see the things. This is a repository. My repository is named the Linux Shell Solutions. And here there are different folders. Each folder has a file which contains a code, a certain code that is written in .sh, that is shell script. So this, you can see it is very well organized, different folders for different topics. Then there are codes in different folders. There is a readme.md file, and this is the description that I had written. And I could show you a better repository which would have like a good readme, because I wanted to show that. Just a minute. Okay, maybe this one. This is the page that opened up on the front page. This is also basically designed using the readme file. When you create a repository which is the same as your username, the readme to that repository comes on your front screen. So this is what it is looking, but behind this, I would like to show you how to write a readme. So there's a few things you need to know about writing a readme. One hashtag, hashtag is used for writing headings. One hashtag makes extremely, you could say, big characters, and the number of times you increase the hashtags, the size of the characters go on decreasing. Then you can add smileys, and then if you want to add images, you use the simple HTML command that we have for adding images. So writing it is when you want to highlight something, you use this symbol. It is present just below your escape key in your keyboard, and so on and so forth. These are when you want to add links. So writing a README file is quite important because it describes the person what your repository is all about. So I always suggest that whenever you create a repository, you definitely add a README to it and you create a good README for that one. Okay. And the other things, so this is where you find the repositories. Now the good thing that you might have noticed, I have a list of all the projects that I've worked on, and all the repositories are present there. So anyone, if the person wants to know what am I skilled at, what have I done previously, or what can he put me up to work with, if my recruiter wants to see through my talents and get a practical view of what I know or what I don't, he could definitely go to my account, visit my repositories, and he'd have a fair idea. Okay, these are the things that she developed, means she knows these things. Okay, so one good thing that I would like to draw your attention to is that we were all talking about collaborating and using GitHub for collaboration purposes. So how do we collaborate on GitHub? All that we talked about was making repositories and projects. So I would show you a simple one. Like this one you see, this is a Microsoft project, which is for an IoT page. Okay, they're developing a website for IoT developers, for beginners into IoT. Now there are about 20 of us who are contributing to this project. We are 20 of us who are working on this project, who are making it, and we are making it in different languages. So all 20 of us, we belong to different regions of the world. There are people from America, from Australia, from Pakistan, from China, from everyone. So how do we collaborate? We don't even know each other. So we're using GitHub. What we're doing is every time any one of us develops something, writes some code, or puts in anything, we just, what we've done, we have forked this repository, we add the changes to the repository, and we create a pull request. After we create a pull request, if the owner of this repository finds the code to be fine, he would merge it and the code would be there. If there are any conflicts, if there's anything wrong, if there's anything wrong with the code or wrong when you apply the code in your project and it would just stop some functionalities from working, GitHub would automatically point out that, okay, it has some conflicts which needs to be resolved and it cannot be merged. So right now I came up with a lot of words which might have confused you all. So for that, we'll go back into the theory part of it. I just wanted to show you a brief overview of what a collaborative project looks like. Like you can see the last commit, it was made by this is basically a forked version. I'll show you the original version here. Yeah, so the last update was made by Ifito. I think this is not his real name. He's from America. So he made this commit 3 days ago. Okay, and these are the people who are contributing. They're like 12 of us are named here. The rest haven't been added. They haven't been put up here. And whenever anybody makes a change, the person creates a pull request. Okay, like this pull request was made by Cool Aryan. He fixed some grammatical errors, and now if the owner, that is Microsoft, if it finds that the changes that it has made or the corrections that the person has made are fine, they are to be accepted in the project, they will simply accept it and it will be added to the code. The code would be updated and it would have a new functionality in it. Simple as that. So you are making a code. Here Microsoft is making a code to create a website. It has like 10 or 12 or 20 people working for it. These people come up with their own ideas, their own thoughts, their own changes, make the changes in a copy of the repository that they have with themselves, and just request Microsoft that, okay, these are the changes that I've made. If you find them correct, merge it in the code. Now Microsoft goes through it. Basically, GitHub goes through it. If GitHub approves it, Microsoft generally accepts it. So if they find it fine, they accept it. Once it is accepted, it is merged into the code and it is a part of the project now. So any change that was desired that I wanted to put up to this project or anything was directly merged into the code. I did not have to go there. I just had to write it on my own. And the other person could easily check if it's fine, could merge it. And so there are like 20 of us working on it. We do not know each other physically. We have never met. We have no idea about what the other person does, looks, or talks like. But we are working together on a project. Together, we are making this project. When it is up there, all of us will be credited because we will be part of a team who's working for it. So it's that way. We are collaborative. We can collaborate with anyone around the globe, and we do not need to be together. And this is one of the most important things you need to know because you're all at your homes right now. If you're working on a project, on any project that you want to submit for your tech fest or anything, you want to be together, right? You are at your homes. You can't move out, and after the 2 o'clock, it's like the curfew time here at Bihar, so you can't move out of your homes. And so how do you work together? So GitHub is the way you work together, and GitHub is the way you submit your projects to your evaluators. You just give up your repository link, the evaluator opens it up, runs it on their computer, and just checks it that okay, it's working fine, or he grades it accordingly. So I have just given a brief overview. I'll just go through the terms that were attached to it so that I can explain better. Now, one of the important terms attached to any GitHub account is branch. Now, when you create a GitHub repository, you have actually created a project file, right? You have your folders up there and the files, the images, the codes, and everything up there. So it is like a project folder, you could say, or a project masterpiece that you've created. Now, there can be millions of ways in which you can work into that project. Maybe you can create a copy of that project, okay, and work on it. And if you find that copy to be working fine, then you can merge it with your original project so that all the changes are merged. Or you can work, or you can add the things in that same project file, but you do not want it to be visible to anyone, or you do not want it to be included into it. Right? You create a branch. The entire code is present in that branch. The entire file structure is present in that branch. Now, what you do, you make your changes, okay, and you edit everything in that, and you test if it's working fine. If it works fine, you merge it with your original branch, and then you have an updated code. Now, why do we need a branch? Branches are created in the same repository. Like if you're collaborating and there are other people working on your project, they do not create a branch of your project, they create a fork of your project. But when you yourself, you want to create a copy of your repository so that, you can, just as I said, you can make changes and see if it works fine. So if you want to create a copy of your project and you do not want the original project to be affected with the changes you might make because they might be correct or might not, at that point of time, you create a branch. Okay, so one branch is there, which is perfectly safe. No changes are made there. That can be used anytime you want. You have another branch which you just created with maybe a different name. The name of repository does not change. The name of branch changes. So you create a different branch. Whatever changes you make in this branch are not going to affect anything in the other branch where your original code is saved. If your changes look fine to you, you merge the two branches, and then you have an updated code. Like I'll just show it to you what branches look like. For instance, one second. This is my repo. I just create another branch here. Okay, I'll create a branch named new. Okay, create branch new from main. Okay, there'll be a branch named new created. Now, in both these, in main that was initially present, I have the entire code, the Readme file, and everything. In the branch new also, I have the entire thing, the complete code and the Readme present. But the change would be whatever changes I make in this branch, the branch new, would not be updated on the branch main until I am satisfied with all my changes and I want to merge the two branches. That is to merge the two codes and just update both of them with all the changes that are present. So I would make any type of changes that I want, any type of editing that I want to do, and just check if things work fine with those editing. If I am happy, I'll merge it. If I am not happy, it's all right. It's in a different branch. I don't need to worry about it. Okay? So when you want to do some experiment with your own repository, you create a branch. Okay? Now, next. Pull request, as I said, uh, when you work on a project which is collaborative, there are different people working on it. You make one change and then you create a pull request for that change. That pull request is sort of, a request alerting the owners of the repository, or if you yourself are the owner and you're merging two branches, then it tells you about, okay, that these are the changes that I made. Like I just showed you a pull request from a person who had made some grammatical changes. So a pull request is like a log of the changes that you made, and you want to merge it to the original code that you have, so that you have an updated version of the code. So you create a pull request. The owner checks if the pull request is fine, that is, if the request of the update that you want to make in the code is fine or not. If he finds it fine, he'll merge it. If he does not find it fine, he'll just reject that pull request. Okay. So pull requests are, you could think of, as a log of the changes that you have made, and you are wanting those changes to be implied on the real code. So merge is, of course, as we've been discussing, so on and so forth, the union of two branches or two repositories. Commit. Okay, whenever you make any change in GitHub, any change, even if you add one word to your code, one word to your README, you add a new file, you delete some file, you need to create a commit. Okay, you just like we save the changes, you need to commit the changes. Now, commit is it would be present at the bottom of the page. So when you commit a change, it is like, the changes are saved. Now, why is it such an important thing? Because GitHub is all about keeping a log of all that you have done. Supposing you have made some changes by mistake, you have committed it, you can always go back to the previous commit or the previous change that you made, the previous state of your code, and get back to, the non-mistaken stage. So every time you commit, a commit is associated with a message. Generally, when developers, they make a commit, they put a commit message which would display the purpose of the commit. For instance, if I've added image files, image files may be related to this workshop. If I create a repository of this workshop, I'll add the PPT and maybe the images. So I'll just add the images. When I commit the images, that is when I save the images, I would write a commit message reading adding images. Okay. So when I next scroll through my commit page, I would see the changes that I've done, and I'll see that, okay, maybe on 7th June at around 7 p.m., I added some images to it, and the images were about the workshop. But now I'm not happy with the images that I added. I did not want to do that. So I'll just go to that commit point where I made the change, and I'll just click on just get back to this stage. I'll get back to that commit stage where I added the images, or maybe the one before that where there were no images, and I'll restore my repository to that state. Now I do not want any images to be present there. So that is what a commit helps. Now, if you're working in a big group and people want to know what are the changes person A made, there's some head who wants to know what are the changes made by person A in this repository. So if you have the access to that repository, you would just simply make the changes. So that person, that head, would go through the commit file, look for the changes that were made by you, by person A, the commits that were made by you, and he'll just check that, okay, these are the works that you have done. At this point in time, you added this, you committed these changes. So if this is not what we want, we'll just have to delete these files. You just have to undo this commit. It's like a log of the activities that you do. Okay. Now, fork is like one of the most important terms when you're working about collaborating projects. So what fork does is branch simply created a copy of that project into your own repository, into the very same repository. Now, if you like some project, okay, for instance, I'll show you many of the repositories that I have are forked actually. So I'll just show you some random project. Maybe this one. Okay, this is just a repository about coding interview questions that might come. This is like a very good repository. I started it. Whenever you start a repository, you get a list of it in your profile. So you can go and check that what are the updates made to that repository, or you can anytime go to that repo to have a look again. Or you can watch a repository. So whenever there's some change made to that repository, you'll get an email alerting you that, okay, such and such changes were made to that email. So now what I do, I'll fork this repository. So you see there's this structure of the entire repository. As soon as I click on fork, I'll get an option to fork it to my account. Now, I now have a copy of that entire repository on my account. Okay, now this was some Juesham's account. I cannot make changes to code of someone else, right? But if I like his code, if I like his work, and I want to maybe add something to that work, or maybe just check each and every file of that, or just make a few changes and see how it turns out. So I will need the code for my own, right? So for that, I will fork it. After forking it, I will get a copy of that entire repository into my account, into my folder. Okay, and now I have a copy of it. All the changes that I make are allowed to be made, and they will just remain like normal changes. I can make as many changes to it as I want. It won't affect the original repository. And when I'm happy with my changes, when I am satisfied with the changes that I wanted to do, I can create a pull request. And as soon as I create a pull request, Dwesham, whose repository it originally is, will get a notification that okay, some pull request has been created. If he likes my changes, he can merge them. If he does not like it, he won't merge them. But if you want to work on a repository, you initially have to fork it. Okay, so if you end up collaborating into some project, like if a group of 5 or 6 of you start working on a project, so what you'll do, one of you will create a repository and the other 4 of you will fork that repository. Now every time any of you makes any change to that repo, you'll just create a pull request. The initial person who made that repository will get a notification, and he would merge the request, merge the code changes that you've made if they're fine, and if they're not, he would give you some suggestions or whatever. And so that way you can work, and every time you can update, like here you can see this is written, this branch is even with the one that I forked. So if there are some changes made in the initial repository that are not with me in the forked version, I can actually fetch the changes. Here's this option of fetch upstream, so I can fetch these changes back so that I have the updated version. So all of you will have a copy of the code, all of you can work on it, and then if you make good changes, you can create a pull request to be merged to the original code. Okay, sounds very interesting to work with and very easy flow. It's a very easy flow. Just fork it, make changes, create a pull request, and it's up there. It's very easy to work with, and that is one of the best things about GitHub, that it makes collaborating on projects just so easy. And if you start working on GitHub, you'll find such interesting projects out there which you would really want to work on yourself. So for them, forking is a very good feature. You fork your project and work on those projects on your own to see what you can make out of them. But one thing should be remembered: whenever you fork a project, there would be a line written here. This is to prevent people from calling work of some other person as their own. Plagiarism and all can be prevented. So you'll always get this message that okay, it was forked from someone else's repository. This is not something that you created on your own. So far, so good, I suppose. If you have any questions, you can put it up on the comment section. And this was fork. Now, fork versus branch. I hope I have explained it quite well. So, branch is something that you create of your own repository, a copy of your own repository, so that you can experiment with your own code while not touching or harming the original one. And forking is creating a copy of someone else's code, some other repository which is not your own. Okay, so it's very basic. If you want to understand it, it's very basic to know what it means. Now, I just told you about the watch feature. Did somebody say something?
Manvi, can we ask something?
Yeah, sure.
Manvi, there is very much questions. I can ask you one by one. How to use Tinkercad Classroom?
Okay, Tinkercad Classroom. Sure. I can demonstrate that. I was under the impression that it is not to be used. So, basically, Tinkercad Classroom, when you want to create that, you do not, when you start creating a Tinkercad account, I'll just have to show that. Wait a second. Okay, Okay, so when you do not have an account on Tinkercad and you open it, it would look something like this. So when you start to join it, there would be three options. What people generally create for creating projects is to create a personal account. That is what I had done. If you already have a classroom created by your educators, you simply get the code for that classroom and you join the class. And if you are an educator, that is, you want to create a classroom wherein you can teach people, wherein you can give assignments. It is very interactive, I tried it for DSC once. So you create a classroom wherein you can assign assignments to the students, get a record of the students that you have and everything. For that, you need to create an account from here. It would have a different process for making an account. Maybe it requires some verifications. But if you want to create a classroom, you go from here. If you already have a classroom, you just need a code which you need to put in here and you're good to join. And if you want to go for personal development, you simply create your own account.
Manvi, one more question. Is there a way to get Tinkercad to recognize WebGL?
To recognize what?
WebGL?
WebGL, I don't hear that.
Okay, then can you explain the use of transparent option in Tinkercad?
There was, one second. Just let me sign in so that I can show it. Okay, where was this transparent option? Who was asking that question? Because there's nothing as such transparent here. I haven't ever seen anything as such transparent while working with Tinkercad. But if you say there's something like that, maybe it's just to make the device not visible. I don't see it anywhere. In my entire time of working, I've never come across any transparent option. If you could just say where it is.
We should go for next.
Are you talking about view and hide option? Because if you're talking about this is just to hide the component that you've selected. If you're talking about this. If you're talking about this option, it is about the hide. It is about the hide the component that you have selected, or to hide the code window, just to hide the present thing on the screen. For that, this option is used. Okay, next question.
How to share Tinkercad project gallery with anyone?
There's this option here to export. You can export in .brd form, and you can share. You can share a snapshot of your code. The two best options. Otherwise, you can, as I was explaining, you can take a screenshot, put it as an image on GitHub, copy your code from here, and put it as a thing on GitHub. So GitHub or export and share option from here.
Manvi, next question. What kind of projects can Tinkercad be used for?
Depends on how creative you can get. Like the screen that you see here is about a speaker, which can create piano type sounds. If I start its simulation, it can create different sounds. So you can add a number of keys to this and create a piano. It like depends on your creativity. Though there are less sensors present, but there's no limit to creativity. So the more creative you are, the better you can make.
Can we design 3D project on Tinkercad?
Not with this option. There is another option to design 3D project, though you can, but not with circuits option. Just a second, I will show you. Here, there is an option to create 3D designs. You can go on creating a new design, and then you'll get options related to it, and you can create the 3D design you want to. Like, it's easy to make from here. but not using the circuit options, using the 3D design option. Next question.
Not more than this one. Janvi, it is very useful session. Participants enjoyed a lot. We have no more question till now. Varsa, you can proceed.
So, thank you very much for joining us, Manvi. We are happy to be with you. I hope your presence will with us forever like this in coming days. Once again, thank you for giving your precious time to us. That's all.
Thank you so much.
Thank you so much, Manvi. It was absolutely a fantastic session. We got nice feedbacks from the participants. All the Prava team is thanking you for this awesome session. We should end our meeting now.
Okay, thank you so much. It was very good interacting with all of you, and I hope I was able to give a good message to everyone.
Yes, Manvi. Thank you. Thank
Thank
you,
you.
all of you.